Today I am going to discuss a very important concept in mechanics, that is friction. I am DATTA sir. I am an ex-senior professor of a number one IIT in India, and also I am teaching IIT students for a long time. And I am making videos on various concepts of physics for the benefit of the students, and particularly for those concepts where students are struggling. So I have seen that many students are confusing in the case of friction problems. So I am presenting this video. Please listen to this very carefully. So I am going to the concept directly. So concept is static and kinetic friction. Now let us say in the green diagram, a box or a block, anything you can imagine, is at rest on a ground, and it is a rough ground. So if a force is given to the box, and there is, you know that there is mg downward and n upward. If a force is given to the box, if the force is not very big, then the box may not move. But if we keep on increasing the force, then also it will not move, but at certain time it will start moving. So what happens? It is when it is not moving, definitely there is a force opposing capital F which is applied. And that force is nothing but the friction force of the surface. That friction force is working opposite to the applied force. And these two forces have to be equal, because unless the net force is zero, the box cannot be at rest. So box is at rest for some time. So long it is at rest, F has to be equal to F, small f. That means applied force has to be equal to the frictional force. Now when F is increasing, definitely this frictional force is also increasing, because it is not moving. So long it is not moving, they are equal. So long it is not moving, when F increases, small f is also increasing. And this type of friction, when it is not moving, means, to be more precise, when there is no relative velocity between the two surfaces. That is the guiding word. If there is no relative velocity between the two surfaces, then it is called static friction. If it is at rest, then if ground surface is at rest, box is also at rest, so there is no relative velocity. If the surface is moving, then if box is also moving with same velocity with the surface, then there is no relative velocity. Then this will be also a case of static friction. So when box is so long, box is at rest, there is static friction, and that static friction starts from zero and increases with applied force, and always it is equal to applied force. But when we go on increasing the applied force, you will see that at one time the box starts moving. Means force is increasing, but the friction has reached its maximum. It is not increasing anymore. That is called maximum static friction. After that, the motion will be due to the net value of the two forces. Means applied force is F and the friction force maximum is F max. And that F max, maximum static friction, is equal to mu into n, where mu is a constant and n is a normal reaction. Static friction is from any value between 0 to mu n. Mu n is the maximum value. And so far box continues its motion, the value of friction remains constant. That is called Fk. By Fk we mentioned, and that is called kinetic friction. Again I am telling, so F max above is called maximum static friction. We write Fs. Fk is called kinetic friction, which is also constant. And you know, Fs and Fk are almost equal. They are not exactly equal, but almost. F Fs is slightly Fk is slightly less than Fs. But for all practical purpose, we often write Fs equal to Fk, and both we are writing as F max or Fs. So we come to next line. Fs is so proportional to normal reaction. This is called law of friction, or we can write Fs equal to mu s into n. Similarly, for static friction, kinetic friction also we can write Fk is mu k into n. These mu s and mu k are called coefficient of friction. Mu s is called coefficient of static friction, mu k is called coefficient of kinetic friction. Or in general, we can write F equal to mu n, when F we can write coefficient of friction, because they are almost same. Sometimes we write like this. Now this F max or F, whatever you write, it depends only on normal reaction, but it does not depend on area of contact between the surface. This you have to note very clearly. This is law of friction. Law of friction says F max is proportional to normal reaction, but it is not dependent on area of contact of these two. Now, I am giving the tips to solve the friction problem. This you will get, but very often you students confuse on this. So I am giving the tips point-wise. See, we have to find normal reaction, and normal reaction is not always mg. Very often students confuse F as mu mg, they write, but it is not mu mg always. It is mu n. If n is mg, you can write, but it is mu n. But very often n may be other things than mg. So you have to write mu n. So n we have to first find out using free body diagram. This is number one. Number two mistake students make, they often write static friction equal to mu n, very often, but static friction is not mu n. Only the maximum of static friction is mu n. Otherwise, friction in other case, we write is as F only. Its value is from 0 to mu n, anything between them. And we have to find the value by solving various equations. So these are 2 points you have to note very carefully. And third is kinetic friction is always mu n, or you can write mu kn, but in general we write mu n. So these 3 points you note down very carefully. I have written this because students are making mistake on this. First thing, static friction, blindly you don't write mu n. Only maximum of static friction is mu n, otherwise static friction is anything between 0 and mu n. And it is mu n, not mu mg. N has to be found out by free body diagram, then we write mu n. And kinetic friction is always mu n. I am giving an example. Suppose two masses, one small m and another big M. Small m is on big M, and they are lying on a rough surface. Now, the upper mass is being pulled so that the entire two blocks moves together. That means there is friction between the blocks as well as friction on the surface. Let us say coefficient of friction on surface is mu1, coefficient of friction between the blocks is mu t. Now, see, there is no relative velocity between the blocks. So the friction between the blocks is a static friction. So the value of this static friction will not be mu n, will be anything between 0 and mu n. So we call it small f. We do not write mu to n. But in the lower surface, the block together moves on the lower surface. So there is relative motion. So lower surface, the friction is kinetic friction. So their friction we will write mu 1 into n. And we write there mu 1 into n, and we have to find n. So what we write, the equations we will write like this. For upper mass, we will write there is a force acting capital F, and there is a frictional force. We will write that as small f, not mu n. So we will write capital F minus small f equal to ma, if a is their common acceleration. For lower mass, we will write there is only one force for lower mass, that is small f, because small f acts in forward direction on upper mass and in backward direction in lower mass. So on lower mass, the only external force is small f. So we will write, and another external force is there, that is frictional force. This is mu 1 n, or here n equal to m plus m into g. So we will write as small f minus mu 1 into m plus n into m, capital M plus small m into g. That is second equation. Now what we will do is, we find this two equation we will have to solve. So that is algebra, we will do it according to that. So this is the way we apply friction. So why I have made the video? Because I have seen students are many times confusing about the friction problems. So again I am telling you, first you decide whether the friction is static or kinetic. Then if it is static, then you don't write mu n, you write f, and you have to find f by equations. If it is kinetic, you write it as mu n, and then n you have to find out by other equations. Sometimes the problems are a bit complex, we have to use 2-3 equations, we have to use that. So I hope the concept is clear to you. So you have to repeatedly see this video, and you have to note down the points also and clear your concepts. Then friction problems will not be very difficult to you. So thank you very much for listening. If you are benefited, please like this video, share this video, and subscribe to this channel, because I will be coming to you regularly with new concepts on physics, particularly those where you find problem. And if you particularly want any concept to be discussed, please let me know in your comments. So thank you very much.